Microchips power virtually every electronic device in our modern world, from smartphones to spacecraft. But have you ever wondered how these incredibly complex yet tiny components are manufactured? The journey of creating a microchip begins with one of Earth's most common elements, silicon. Silicon is extracted from sand and purified to an extraordinary degree, achieving a purity of 99.99999999999%. This ultra-pure silicon is melted at temperatures exceeding 1,400 degrees Celsius and formed into cylindrical ingots. These ingots are then sliced into thin wafers less than 1 millimeter thick. The wafers are polished to achieve a perfectly flat, mirror-like surface, so smooth that any imperfections would be measured in atoms, not millimeters. The heart of microchip manufacturing is photolithography. This process begins by coating the silicon wafer with a light-sensitive chemical called photoresist. Using specialized machines that cost millions of dollars, manufacturers project microscopic circuit patterns onto the wafer. Modern extreme ultraviolet lithography can create features as small as 5 nanometers, thousands of times thinner than a human hair. After exposure, the photoresist is developed, leaving a pattern that protects certain areas of the wafer while exposing others. The exposed silicon is then etched away using plasma or chemicals, creating the intricate circuit patterns that will form the basis of the chip. Next comes doping, where specific impurities are deliberately introduced into selected regions of the silicon. This process changes the electrical properties of the silicon, creating the transistors and other components that make up the integrated circuit. Layer by layer, this process of deposition, photolithography, and etching is repeated dozens of times, building a three-dimensional structure of interconnected components. Modern microprocessors can contain billions of transistors, all arranged in precise patterns. All of this manufacturing occurs in clean rooms, environments thousands of times cleaner than hospital operating rooms. Workers wear special suits called bunny suits to prevent contamination, as even a single dust particle can ruin a microchip. Metal layers are added to connect the various components, creating the complex circuitry needed for the chip to function. Finally, the completed wafer is cut into individual chips, which are then packaged in protective casings with metal pins or contacts that allow them to connect to circuit boards. Each chip undergoes rigorous testing to ensure it functions correctly. The entire process, from raw silicon to finished microchip, can take months and involves hundreds of precisely controlled steps. Recent innovations in microchip manufacturing include three-dimensional transistor designs, new materials beyond silicon, and increasingly sophisticated automation. These advances continue to push the boundaries of what's possible, enabling smaller, faster, and more energy-efficient chips. The creation of microchips represents one of humanity's most impressive technological achievements, combining physics, chemistry, materials science, and precision engineering to create devices that have transformed our world. From the extraction of silicon from ordinary sand to the finished product containing billions of precisely arranged components, microchip manufacturing exemplifies the extraordinary capabilities of modern technology.